get us started.
All right, welcome to the second live stream that we have from C4 about account abstraction. So if you tuned into our last episode, we basically covered account abstraction. What are the different accounts that you can have on Ethereum? There are EOAs, which are externally owned accounts, and that's what most people started with. But they're smart contract accounts, and they can enable all kinds of superpowers. And we have more guests with us. We have Jake again. And maybe Jake, you can give yourself an introduction.
Yeah, so I'm Jake. I'm a developer on the Wallet Accounts Experiments team at Privacy and Scaling Explorations, where we work on currently like a lot of features that try to add like additional functionality to smart contract accounts, mainly right now focused around account recovery.
And we also have James.
Yeah, hi there. I used to be in the Wallet Account Experiments team at PSE, but then I recently left to join Aztec, who's building a privacy-preserving layer 2.
And Jerome.
Hi, folks. I'm Jerome. I'm the CEO and founder of Cometh and the president of Ethereum France. I've been working in the space for about 10 years now, and my company Cometh distributes middlewares, mostly for games and retail applications, and notably account abstraction.
And I'm Dustin from C4. I'm the education manager, and I also run a Singapore Ethereum community called E65. And Jessica, who's off camera, is our executive director of C4. So just to cover what we covered in the last live stream, basically we talked about what account abstraction can enable and the superpowers that make it so much better than EOAs. So one of those examples is social recovery. Right now, when you use an externally owned account, you've got to remember your seed phrase. If you lose your seed phrase, you lose your access to your account. If someone steals your seed phrase, you lose it as well. With social recovery, there are different ways of recovering your accounts, which is, you can give it to your friends and family. And if you need to recover your account, you can get it from a few people, maybe 3 people, and then you can recover your account. Other things it enables are things like passkeys, using your biometric sensors, using multi-factor authentication. And I think Jerome brought up games. You can do interesting things with session keys as well. You can do other things like gas abstraction, where instead of paying the native token of the chain like Ethereum or a layer 2 chain that uses their native token, you can actually use stable coins. You can even, as a platform, sponsor the user's gas for them. So you can also do interesting things like transaction batching, where you can do multiple transactions with one signature. And you can do things like chain abstraction, which makes things easier for people to transact across chains. From the security perspective, you can also do things like transition to different signature schemes. Like, for example, in the future, you can do quantum proof signatures, for example. So we have a few guests that are all working in account abstraction, doing different things in the space. So I thought it would be interesting to talk to each one of our guests and see if they have a demonstration from their projects to tell us about how they are using account abstraction, making things easier for the end users. Jake, can we start with you?
Yeah, for sure. With account abstraction, the main thing we're working on at the moment is doing account recovery via email using the ZK email project. And so essentially what that is most emails are signed nowadays using something called like the DKIM protocol, which essentially is just a signature around the data that's inside of that email. It turns out since that is a public key, like cryptography, asymmetric key cryptography signature, we can verify that on chain. And so specifically with the ZK email project, they are also able to hide the contents of the email, but still prove that what was inside of it was correct for what you're expecting. And so essentially, we're using the subject of an email and the signing of that email to allow someone to essentially request and get recovery rotation of the keys on their account. Say if they move devices, they lost it, or their account in some other way has been compromised.
Happy to jump in next. Yeah, so building off that, I guess yeah, from having seen how that works on Ethereum and having to do it at the smart contract level, and then coming into Aztec and just recently learning about how they do account abstraction here, it basically encompasses a lot of the same problems that are being solved via smart contracts, but bakes them into how things are called. So, say going back to fee abstraction, that's something that is sort of done with an Aztec transaction where you specify the fee paying contract. So you can have things, FPCs, fee paying contracts, that will pay in the native gas token for your transaction, but you can set up an authorization for it to withdraw an amount of X other tokens or an appropriate amount of whatever other token you like. So that's where you can do fee abstraction. Maybe later we can go into the sort of some of the designs for that, but like a lot of the things that I've seen in the development of account abstraction for Ethereum smart contracts and all the standards that are coming around that, I just see it get to sort of be enshrined in a way that just a little bit more tighter and cleaner, because you're getting this sort of clean slate to build on, which is quite nice. Like one of the projects that I guess, there are a few projects in this space that are around ZK Passport, but in terms of an application, that's a good one as well, where I think they've got the circuits in Noir that verifies, can generate proofs of elements of your passport. So maybe you wish to prove that you're above a certain age, but you don't want to reveal your date of birth. You can do that with part of the information in your passport. So you don't have to give someone a copy of your passport to reveal certain things. By generating proofs of that, you can use that in a smart contract wallet, which is what all accounts are on Aztec. Actually, there's no EOAs. So again, another interesting detail there. But I'll sort of stop it there.
Cool. On my end at Cometh, we have a game studio in our portfolio, so we are very very close to the gaming ecosystem. We just published our second game on Epic Game Store, Cosmic Battle with a K, if you want to check it out. So we had first-hand experience at trying to expose the retail users to Web3 stuff, specifically in gaming. That led us to do a lot of work on the account abstraction side, and for what we can tell, and to also follow up on the intro by Dustin, we look at account abstraction as a 3-layer cake. So you have the signature layer, with different providers, different way to sign, and that's extremely interesting. To have different ways to sign, because sometimes the device that you're using is capable of generating some keys, notably passkeys, that we really like a lot. One thing I'd like to stress is that you should make the difference between a passkey that is used to sign and a passkey that is used to authenticate to a service. So sometimes you have an MPC provider, which is part of the signing layer, that authenticate you with a passkey. So it's cool. But you also can sign stuff with your passkey to actually activate the smart account. That's pretty nice as well. That makes also the account abstraction initiative in the industry as some sort of layer of compatibility between layer 2s that not necessarily use the same signing scheme. And that's pretty nice as well. The second layer that we see in the account abstraction is the smart account layer, which can be of multiple form. On our end, we like to work on Safe, the smart account developed primarily for multi-signature, but that can also be used in a 4337 context and in an account abstraction context. They recently released a new version of this, and there are really nice implementation. Zero Dev kernel has one. Let's quote another one, like Alchemy as another one. And from what I heard from Jake, notably, you can have different modules on top of those smart accounts to do cool stuff, like verifying that you are who you said you are, doing some recovery and so on. And we like this a lot in the whole layer cake of account abstraction. So smart account is part of the layer as well. And the last layer that we see in the account abstraction space is the infrastructure layer, even if it's not the right way to put it, but all the bundling and pay mastering of the transaction, like the parties that will be involved to pick up your message and turn them into transactions. So right now, I think what's holding us back in the space is that we have few ways of having a one-stop shop and lots of wiring to be done. We are doing this kind of one-stop shopping and trying to expose it, but so far it's been hard for large-scale projects to figure out how to implement all of those three layers together. But it's definitely something that's a change of paradigm in terms of user experience and user acquisition as a whole, and that's why we are super excited by this initiative in the industry.
Thanks so much for covering that, Jerome. I think we mentioned a couple of things there that I would like to zoom out and give a larger context to, because like you mentioned 4337. So what Jerome is referring to is ERC 4337, which is a standard for account abstraction. But I think maybe if maybe Jake or James, would you like to dig into what is ERC 4337 and why do we look at that as a reference point for for account abstraction?
Yeah. So ERC 4337 is a app specific protocol essentially that allows you to have a lot of the features that we want with smart contract accounts in a way that is a bit more decentralized and censorship resistant. And so it has certain ways in how it allows you to say validate that a transaction, or in their case, user op, is valid, as well as how that is executed. And in addition, the really key part, I think, of a lot of why that ERC is a little complex is there's a lot of mitigation for a lot of DDoS attacks against some of the infrastructure you run to enable things like bundling of transactions, and also for throttling malicious contracts that may invalidate transactions if they, like, say, update too frequently, or if someone attempts to say, like, a paymaster is failing too often. So part of the benefit of it being an app level change is it does not require an Ethereum hard fork. So it just simply requires a specification that people can build on top of, and you can use it on any EVM network that's available today. There are some future changes that may enshrine that or make it a protocol level change. But yeah, James?
Yeah, just to add to that, like I sort of, when I looked at 4337 sort of coming about and yeah, speaking with Yov and Draw about, what they had been working on, I did see it as a kind of evolution of gas station network in a sense, but with more generalized components to it. So yeah, you would have this abstraction of like the ability to have gasless transactions, but in a way, as Jake suggested, in protecting the infrastructure that's running those as well. I guess the wrinkle of detail with with Aztec on that is that rather than having something like like needing to deploy a specific contract that's the entry point contract, with a transaction you can actually specify a private setup function, and I think when you deploy the contract, it's called I think it's actually called an entry point function that you nominate. So in a sense, the logic that your contract will run by is specified by the person running it. There is like some specific sequence that I won't necessarily go into now, where you do declare which public function you might want to be called, but then by specifying the fee payer and then by having things come back at the end and get torn down, you have this sort of self-contained logic that you like. So whilst 4337 has an entry point contract, Aztec lets a transaction specify an entry point function.
Yeah, and to dig a little bit about the history of 4337, first, it's an ERC, so it's a request for comment and supposedly a standard of contract, which rarely gets endorsed by the Ethereum Foundation. Usually, a standard for contracts are like, hey, you want to build a standard, let's have the community discuss it, and it's cool. We reference it with a number everybody can understand. Because usually when we make changes to the protocol, we use EIP, Ethereum Improvement Proposals. And when you dig in the history of Ethereum, we have 2 digits EIPs, like the EIP 86, abstraction of transaction origin and signature from Vitalik back in 2017, that was trying to implement account abstraction at the protocol level. And then 3 years after, we had a EIP 2938 that was in 2020 trying to implement account abstraction another way inside the protocol, simply called account abstraction. And both of those EIP has been proven to be too complex to be actually fully implemented in the protocol itself. And thus, realizing from the core dev perspective and from the EF perspective that we had a challenge to actually implement properly an account abstraction, we decided as a community to start with a standard of contract. That's 43.7, and that's account abstraction using an alternative mempool for the messages instead of for the transactions, and let a community of builders, a community of projects, a small ecosystem evolve from this. And at some point to merge this ERC approach, this contract approach, into the protocol itself. So let's say ERC 457 is a bridge towards getting that into the protocol, and the Ethereum Foundation is like publicly supporting that, like employing private public researchers and private researchers to build on top of that, and distributing grants from people building on top of that. Cometh got one, and other companies got one as well, to help on making this standard emerge and start to have usage, and then grow from the usage that we had, and learn from the usage that we had as a protocol to merge that in the protocol itself. And so it's right now the focus of the Ethereum Foundation in terms of how to do account abstraction in a decentralized manner, in a manner that is aligned with the values of Ethereum, let's say.
Thanks so much for covering that. Would it be fair to say that ERC 4337 is kind of like maybe the equivalent of a standards body, or what's close to it, which is like this is a specification that everyone works toward? And on the other hand, we have maybe wallets like Safe, for example, which are like, one of the earliest smart contract wallets that most people would have used because of multi-sig. But then, as an early leader in the smart contract wallet space, they ended up as well creating some of the standards per se. But then I think only recently they became like 4337 compliant. So like what are the differences between Safe before they became 4337 compliant? What were they doing differently? And how does the 4337 team approach and Safe team approach, where does it diverge, and where do they come together?
So I can't really speak for the Safe team itself. So take that with a grain of salt and from a Safe user perspective. So, well, the first goal of Safe was to provide multisig. It was a project that was incubated at Gnosis initially. I remember back in the days there was a multisig contract supported by the Ethereum Foundation. I think that if I remember correctly, that's probably my only contribution to official contracts. But anyway, so the point was just to make a multi-signature and to build on top of the multi-signatures approach, and create good multi-sig that people can use, and develop the use cases for multi-sigs. I think the main use case right now for Safe, use case in terms of TVL, like how much assets are stored on those safes, is providing a wallet that is shared among DAOs and among DAO members, and eventually as well regulated parties that are using blockchain stuff and want to share the governance. So it wasn't meant to be a smart account with one single signature and a lot of wiring on top of it to let third parties and trustless protocol interact with it. Thus, the whole design of 4337 was made without taking into consideration that 4337 will have to use Safe as it is. So 4337 was built to work with smart accounts that are, let's say, 50-ish lines of code, while the all Safe stuff is more 200 or 300, let's say. And also how 4337 works with the different entry points it requires, with the user up, is valid, and so on. It's not really how Safe was philosophically designed initially. So to make safe compatible with 4337, there was a first attempt that then was decommissioned, and there was a new attempt that is final. It was a stretch in the initial design of Safe, and thus it took more time for Safe to be fully compatible with 4337. As a company that builds on top of Safe, we also support other standards of smart contract, but we like Safe for the sake of security mostly, and proven track record and so on. As a company doing that, we were considering that we were distributing account abstraction, even if we were not fully compatible with 427 in the first place. And now that Safe has a full compatibility to 427, it's better that now we are all aligned with this. And I would say the competitive advantage of Safe compared to other smart account is the history of Safe being safe, hence the name, formal proofs and different audits, the amount of money that is locked on those kind of contracts, but also the fact that from a recovery perspective, you can use your own wallets easily. You can just add owners to your Safe and say like, hey, if I lose this key, I have this one, and so on. You have a few modules that is already available on Safe, of course, and it's primarily thought to be compatible with the multi-signature use case. So that opens up a couple of things as well. But time will tell which will be the most widely used smart account, and if the standards will move and so on. And again, it's from a builder perspective. Like you have the signature layer, the smart account layer, and the infrastructure layer, and it's hard to tell what will be the weakest link and where will be most the value, and what will be the hardest thing to integrate and so on. We are still very early on this smart account and account abstraction revolution.
Thanks so much for that summary. James and Jake, I was wondering if you had anything to add to that.
Yeah, just like sort of seconding the point that I think Safe's sort of track record of what they've done with the multi-sig contract and maintaining versions will show in their implementation of 4337. I haven't looked into their latest, but again, just having confidence in their team and process is a lot of what probably gives people confidence in what's built. Trying to remember the next point on. I've just gone blank on it. Yeah, so regarding modules, like I'm not sure if that's the topic for later, but just thinking that with a 4337 smart account and the ability to have different modules sort of be integrated with a wallet, I wonder how that will sort of play out in terms of like sort of whether there will need to be something like approved modules, or like if Safe is building a lot of good modules, that's awesome because every other smart account that is compatible with modules can use them. But then I wonder, it starts to blur the lines if you have someone who's got a Safe account that is trusted and they have confidence in it, but somehow, installs a different module if it becomes that readily done. So that'll be an interesting thing to see play out, where the code of one base wallet can then be interacting or have a module put on top of it that it may not be as secure or have the same, just have the same confidence in. So that's an interesting point. I don't know, Jake, got anything around that?
Yeah, no, I think even with those modules, so like Safe has an existing pretty lightweight module format that it uses already, but there's a lot of work being done to try to establish like different specifications for modules to make it easier for people to build on those and have them be reusable across multiple implementations. The two leading ones now would be ERC 7579 and ERC 6900, so 6900. And the idea is that if we're able to have these module specs that are kind of separated from the actual implementations, then people can choose different implementations for like the core of their smart contract account. But then all of these interesting modules, like things like session keys, things involving account recovery, things we may not have even thought of yet, people can install those on any account that matches that, say, modular spec. And regardless if it's safe under the covers, kernel, I think you mentioned Akami, there's a bunch of different ERC 4337 implementations. You can use that same module, hopefully across all of those different ecosystems. And so that just makes things more compatible, and it makes it more transparent in terms of when those modules are installing, like what they're doing and what they're asking to be able to do.
You mind if we back up a little bit and talk about what modules are in terms of like how a Safe user might interface with a module, And is it, is it being gate kept in any way? Is there a whitelist that happens? Is there an audit process that happens? Because there are a lot of concerns around, the idea of like whitelisting apps, whitelisting entry points, and all these things is about how much control whoever gatekeeps the access to these apps and modules have over that, and whether you have permissionless innovation. So I'm just wondering if you could like broaden out a bit and talk a little bit about the context of like modules and the levels of like audits and things that you need to cover to make sure that people are using safe modules, for example.
I can give a small sort of thought on that when I first saw sort of account abstraction coming into play, is that when a user uses a wallet, they are trusting that the smart contract that is deployed for them as their smart account is good. And I think most users will just trust the brand of the wallet and trust whatever they can from that surface level, and not too many people will necessarily look at the code. And I think maybe there'll be a list of smart accounts that are verified or have some community voted, community curated list of good smart accounts. But I feel the same paradigm or the same problem exists for smart modules, for smart account modules as well. But yeah, I'll see if anyone else has anything.
All right, it's it's extremely difficult topic, I think, to tackle as a whole. So let me use a parallel explanation with Baldur's Gate 3. I hope you tried this game. When you open up the character creation of Baldur's Gate, you have a basic character. So you choose what your character looks like, and you can customize it. So the basic character is what is your smart account. Like you have your basic character, and then you want to customize it. So I want to have horns. I want to have a scar. I want to have tattoos. I want to have long hair. A mohawk, whatever. Okay, you customize a character. Okay, so think about everything that you customize as the module that you are adding. And it turns out sometimes the modules are not really compatible with the core design of your character. So if you have horns and a mohawk and a tomahawk on the like big spikes in your hair, and you're wearing a hat, what happened? Well, potentially the horns are getting out of the hat, or as the developers of Baldur's Gate found as a solution, like you start to have long hairs and you have a cool hair look with the hat, whatever that you're wearing. So when you consider smart accounts and the modules that you're building on top of it, this is the big problem that you may face. At some point, you are stacking modules on top of modules on top of modules on top of modules, and you have to make sure that those modules and the version of those modules are not interfering with one another, and thus are not creating security problems or incompatibilities and stuff. And I cannot speak from the safe team perspective, but if I were in their shoes, I would be like, you know what, guys, we've built smart accounts for multi-sig purpose. Multi-sig purpose is hard enough, and start to do some modules about whitelisting, about different governance rules between different modules and different things. It's hard enough, and now there is an attempt to do a standardization of how the modules are built on top of. Well, this is I hope it succeed in terms of standardizing how modules are made and making sure that we don't create any hiccups along the way on stacking up different modules. I remember when we tried to do standards for security tokens, notably the ERC 1400, we were like, okay, guys, we need all of those modules all together to make the thing works and make sure that the modules are not interfering with themselves. It was tough, and from a brighter perspective, it's been a while that we've been working on complex. We, at terms of the whole community, have been working on those complexity of smart accounts and modules on top of another. So there may be a way forward, but I think it's going to be difficult to come to a really good standardization of the modules itself. It's fine when you have a recovery module, and then in this recovery module you have different recovery options and sub modules potentially. Maybe the ZK email approach is a really good sub module that can be done easily for multiple recovery aspects. But it's kind of weird, when you think about it. Like you have a smart account with multiple signature, for example, and then suddenly you say like, yeah, but there is a recovery, and does the recovery overwrite everything, or does the recovery overwrite just one key? These kind of simple problems, like the horns are getting out of the hat when I walk, like these kind of things. But it's definitely something that we need to overcome as a community, because Again, when you have retail applications, maybe the user wants to customize their characters, or maybe the applications want to suggest some already customized characters. And that's just how the user experience and the user activity is going to shape out, as at least that's what we've seen over the past 30 years in Web 2. So I guess this is something much needed in the ecosystem, even if it's going to be hard to do.
So I wanted to kind of like go back to kind of what we discussed earlier, where you actually talked about like some of the different groups. So you have Alchemy, who are doing ERC 6900. You've got Rhinestone, Biconomy, Zero Dev, and OKX, who are doing ERC 7579, for example. And it almost feels like the design space is so large that there are many groups that are working on specific ERCs or even EIPs. We'll talk about EIP 3074 and 7702 later, right? But it feels like the design space is so large that there are a lot of competing interests. And I'm on the Account Abstraction Mafia chat, where there are days that you just you don't check it for a day and it's got like 5,000 messages of people arguing with each other. So I'm just wondering, what do you think it is specifically about Account Abstraction where there is almost so much diversity of opinion and like disagreements about the best design approaches to take? Do you think that it's just because the problem is so complex, or is it that there's a big disagreement about the best approach?
Yeah, happy to again just think of the framing of this, that like I feel the objective that we're all here for is making Web3 as accessible and usable as Web2. Like give us the same capabilities that we have in that, like give users those capabilities that they're comfortable with, that do work for them, but in a way that can be more, be it privacy preserving or more secure or less centralized. So yeah, that's what the high level goals are. And of course, there'll be many ways to do that. And if people were each doing their own way and doing their own standard, that wouldn't be great, because then you'll have basically lots of small groups, and then users will go to one product and then it's not compatible with another, and then we're basically in Web 2 again, and until some other standards, meta standards, come to combine those. So I like that we're all starting with these are the standards we need, and I say we as in sort of EVMs that are where these standards are written for, versus just to contrast with sort of native account abstraction that different chains are using. But yeah, from that point of view, I just see that as the starting point, that we are trying to achieve a common goal. And I think by adhering to the same standard, that's a good start, that things will be compatible. Like one wallet can deploy a smart account and know that it will work with an existing network of of relays and whatnot, of just forgot the name, sort of gas paying contracts. But when it comes to implementations, that's, I guess, where it comes to the entities themselves. And yeah, maybe I'll leave it to someone else to say what the variety of that gives us.
Yeah, well, let's not be naive on the multiple different standards. There are various interests and corporate interest and personal interest involved in all of those initiatives. Even if they are hiding, maybe faithfully, maybe not faithfully, or maybe not really hiding behind the design choice perspectives. What we all agree on, and what potentially our portfolios and our bags are agreeing on, is we want to make Web3 more accessible. That's a known fact. Like we all agree that it will be better if people will be not having a hassling of installing a wallet and writing down 24 words and blah blah blah, and doing a KYC with the face and so on before being able to even use a crypto app and so on. So we all want to make Web3 more accessible, and we start to almost all agree. And by we all agree, I mean all the people that are trying to provide solution to onboard, between MPC companies, between wallet as a service company, between threshold signature scheme company, between wallet company as a whole, between the big players like Coinbase and so on. They all start to agree that Account Abstraction is a very good candidate. Now, what is sitting between we all want to make Web3 more accessible and Alice, as an individual or as a company, wants to be the one making it more accessible and having good successes at making it more accessible. There's always been in large networks a first mover advantage. So I'm not surprised that multiple standards or multiple alternatives or tryouts compared to 4.2.7 are emerging, saying like, hey, you know what? Like, I get this approach that is slightly better in this and slightly less good at this, or almost nothing, almost not less good, but it's fine. Let's do my thing instead of your thing, and trying to embark people around it and trying to push people around it and trying to make it happen, because the 4.2.7 approach is hard. It's definitely hard. The layers that I was describing between the signature, the smart accounts, and the bundling are hard to wire together and hard to execute together. So anytime you are introducing a point of centralization in those three layers, you are making the thing much easier to implement and to run. Thus, it's really cool for it's really interesting to try if you have good capital and good engineering resources to say like, hey, I got ERC XYZ and EXC XYZ is account abstraction as well, and it's fine. Look, let's do it. And sometimes you have also how to say it nicely, like alternatives to account abstraction that get popped up and pushed hard, like 3074, and thus like it's other ways and other approach, and that's all very controversial talk and all very controversial issues. So I don't want to tarnish my reputation or appear as an angry man, but yeah, there's lots of standards, but let's remember that we've been trying very hard to push for 4.3.7 for the last 3 years, and the amount of brain powers and audit and trials that have been done is already pretty high, and that's most likely the approach that will be supported at the protocol level later on. So it's worth trying it.
Thanks so much for covering that. James, I wanted to ask you something, which is because kind of like Aztec kind of does native account abstraction at the layer 2 level. What do you see to be the differences of being able to do it kind of natively at a layer 2 level versus, the difficulty of getting it implemented at the layer 1?
I think the difference there is just perhaps it's not too much about the layer 1, layer 2, but it's about the virtual machine. So the Ethereum virtual machine is all the smart contracts that are written to do account abstraction with that way. And the way the EVM works is sort of at a more granular sort of bytecode level. I guess, let's say the extra functionality that's in the Aztec virtual machine, which is, like a ZK VM, is just has these additional checks you can do around the setup and tear down. Like there is a list of functions that I can, again, probably to not go into, but like you can deploy a contract, like just starting with that, like an account is still a smart contract. So that's sort of comparable to how things are implemented with the Ethereum standards. But you can first, someone can deploy a contract and register that as a class. So that's already one difference where you have classes and instances of them, which is, again, building something into how Aztec works that is sort of done at the moment on top of Ethereum and smart contracts, like the transparent proxy libraries that Open7 have, or implementations like that, where smart contract has its address and its memory storage, but points to an implementation, and any function that goes to it as an address gets passed to the implementation. This design is similar to what Aztec has in terms of classes and instances, and that's just one example. Regarding accounts, it could be the same way that you have the functionality of specifying an entry point function gives you that capability of basically what's in an entry point, 4.3.7 entry point smart contract, where it will check the function's logic to say, is this going to pay me enough? Is it satisfying whatever criteria it wants? And then saying yes, and then actually executing the call if it satisfied the criteria. So it's sort of two ways to do the same thing, but because Aztec is currently writing its protocol, or is fair way along, I should say. it's it just seems you can like you sort of foresee what people are trying to work around now at a lower level. So it's a little bit easier and better in some ways.
Thanks for that perspective. So
I wanted to add one thing on that as well. I think one of the big advantages I've heard as well is that these protocol layer, like layer 2s doing the native account abstraction, one of the nice things is it's more of a greenfield way that you can kind of build that. And so when we build account abstraction, or we're trying to build 437 and these other things on top of the EVM, we generally have to take into account all the stuff that's already there, right? Because there's a ton of value, there's a ton of projects already on mainnet or in other EVMs. And if we were to make a change that would break that or break other parts of the system, that would be very bad. When you have a like newer layer 2, or you're using a non-EVM code set, you can do a lot more experimentation, and there's a lot of different things you can do outside of those constraints. And so that allows you to potentially build things that we cannot do potentially inside the EVM. And the cool thing about the feedback cycle with that is the things, say, Aztec is doing with their native account abstraction. If there's something novel or interesting there that cannot be done in the EVM, that might be part of a feedback loop that feeds into future improvements to the EVM as a whole. So I think that's also a major advantage you have by doing the layer 2 kind of native account abstraction.
Yeah, and I guess the core of Aztec's sort of what it's doing is privacy, and so by having at that level the ability to have a private execution environment for your accounts, for your contract logic, it's just very, very, very nice, and all the cryptography on top of that, that's something else.
Yeah, let's remember that the EVM is a really nice machine that we like to work with. We like to push to the limit, but we have to all agree that it's not good for a lot of things. So it's great that on other blockchains and on other layer 2s we have alternative VMs that we can very much experiment with. I'm following closely what Aztec is doing and what the other VM with the ZK approach are doing. It's super exciting to see a lot of this happening. I like to work on WASM personally, and knowing that we can bring compatibility through WASM to EVM layers, like what Arbitrum is doing with Arbitrum Stylus, is really exciting as well. And also in the context of account abstraction, when you start to do it in the EVM, you can fairly straight away ask, but what's the overhead in terms of gas? Like how much more fees I'm going to have to spend to that? And that's something that when you are on a native account abstraction, you're like, yeah, no, there's no overhead, it's native. And when you start to add other signature scheme than just ECDSA, like your classic signature 0x address and so on, there is an override in gas. And if you sign with passkeys, there's an override in gas as well. If you sign with a quantum proof algorithm, there's an override as well. So that's one of the advantages of having multiple VMs and having a native approach towards the account abstraction is like we are saving a lot on gas and optimizing a lot.
Yeah, Jake, thanks so much for bringing up that point, because I think we, in a previous live stream, we were actually talking about Dan Kun, and we're talking about self-destruct, the survey that the EF commissioned with DDoP to make sure that, whatever changes they made to self-destruct, what contracts does it affect, what approach should they take with removing self-destruct. So it's a really good reminder about how stuff on the EVM, there is technical debt, but there's also value on chain that you need to be aware of whenever you're making changes. And having a design space like L2s where you can do some experimentation there, and if it bears fruit, these are things that can make its way back into the L1 because it's been proven in a design space where it's not constrained by those considerations.
There's an important aspect on technical debt, but also I think on technical capital that needs to be balanced with that. Like if you've been in the space for a few years, you're like, hey, I learned how to use the Solidity, how to code in Solidity. But learning how to code in Solidity, I was learning how the machine is working. I was learning how the thing was actually reacting to me, to this line or these other lines. And as an industry, we learned the pitfalls of the EVM. So when we switch to another VM, or when we try something else, or when we try to have two systems running in parallel in the same place and things like that, we bear the risk also of losing our part of our technical capital, like what we have accumulated in knowing how the thing works. So I in the past I've been very attracted to, yeah, there's a new thing, it runs super fast for this specific application. Wow, look. And I'm still excited when I see new whirring engines. But I'm also like, yeah, but this one I know how to cook with it. Like I know this oven. I know how to use this oven. Look, it's not let me down. Like I can do my focaccia with this, no problem. That's kind of the thing that we learn also with the different VMs, right?
Yeah, I think of sort of the example with banks and the old languages they still use, because there's some an
Fortran,
element of
right?
security. Yeah, for like yeah, if you, can't remember the other one, but yeah, some old languages that they
COBOL is the other
just
big one, I believe.
COBOL being the other one. Yeah, yeah, it's just sort of what they have confidence in and what they maybe don't want to move for that same reason, that they've got a lot of capacity who can deal with that. But then on the other hand, like, you know, I love Ethereum. Have worked at the foundation for a few years and like within PSE, and definitely like the EVM from before that. And I thought, great, this is where things are. Then I sort of was thinking, okay, there is something out there. What would it be? And yeah, sort of Aztec sort of grew on me because of the capability that it brings. But yeah, maybe I'm sort of deviating. Like, you know, as much as I like the EVM, I think it's great that it remains solid for what it's doing. And we try to add things at the smart contract layer. So in a sense, I sort of look at the smart contracts as the experimental playground. Like I look at account abstraction, what modules might pop up and for smart accounts. But then, yeah, those at a conceptual level can just as easily go the other way as well. So it's not maybe just an L2 informing what could happen on L1, but yeah, it's just, you know, two different areas where the similar problems are being solved, and we're all building in the open and all learning together.
So I think we've tiptoed around the topic, which is why I actually started this series of live streams to begin with, which is like, you know, the big furor was EIP 3074 and the pushback that the account abstraction community had when it was considered for inclusion. So just an overall summary, in all core devs execution, there was a discussion about EIP 3074 being included into the next hard fork, which is Spectra. And essentially the account abstraction community was I think the response was that if they felt blindsided by it, because even though EIP 3074 had been in the works for a few years before it was considered for inclusion, it seemed like the kind of account abstraction community was unaware that it was that close to being included. So when it was included, there was, you know, thousands of messages on the chat, people reading through the spec and going, "Oh, this actually affects, you know, the project I'm building," and there were a lot of disagreements about that. What's your personal take? I don't expect you to speak on behalf of any of the teams, but what's your personal take on what you think the disconnect was between the writers of the EIP and the 4337 team and the overall account abstraction community?
So there's no such thing as a 3074 team. There's authors of the 3074 EIP.
Yeah,
And
the authors, sorry.
I think overall they were all writing and acting in and proposing a change that is interesting for Ethereum. The this EIP was created in 2020 and was received with puzzled reactions from a lot of core devs and a lot of outspoken person in the ecosystem. Notably about the interest at stake for some companies, some wallet companies, to retain a positional advantage in the space. Like there is a thread on the Ethereum Magician that I shared it in the chat if you want to check it out. There's people from the Ethereum Foundation jumping in and ranting about the things. I don't know if those rumors are true. I don't want to like fuel the conspiracy and so on. But the thing is that 3074 let you do is to say like, hey, I'm signing a message, and now this contract can do things on my behalf. So it's basically letting all EOAs dump their EOAs form and switch to an invoker, not necessarily a smart account, but an invoker, someone that will be able to invoke transaction in lieu of the initial EOA. That's creating a lot of potential middlemen and a lot of centralization points towards the invokers itself. That was probably one of the main concerns and the main critics about this EIP. I'm sensible from a security perspective of the argument of, hey, there is a pop-up on this website. I'm signing this message. I'm not sure what I'm signing, but I'm signing it anyway. Oh, too bad. You just signed that this invoker has now full access to your thing, and you lost everything. I'm sensible for this about this argument, but honestly, it's not that bad of a deal. I think the problem of having invokers as an alternative to account abstraction is the most troubling thing, knowing that we spent 4 years both at the ecosystem support level and at the industry level trying to construct that something that is aligned with fully aligned with the value of Ethereum as they are pushed by the Foundation. So which is 43.7. So the reaction after the inclusion on Pectra was harsh. Like the the dumpster fire discussion on the Telegram group of Account Abstraction was interesting, and now we are like, okay, let's find a middle ground and say like, we can make the EOAs evolve towards a smart account and do it properly. Let's not botch the migration. And I'm glad we are getting 7702 instead potentially, because it would have been a few step backs from where we were, and I was very surprised to see 3074 being added last minute to the agenda, and people be like, yeah, why not put it on Pectra? It seems quite final, and the core devs that are deciding whether to put things on Pectra and so on are just considering the technicality of the thing, knowing that it can be implemented. It has already been implemented. So yeah, let's add this. It seems like we've been discussing that for long enough. But right after, people were like, what the heck? Like 3074, no, those are the problems. And now we are moving back. So I think it's a healthy governance talk overall, and an healthy checks of power and checks of different consideration and security consideration and technical consideration as a whole. As in, okay, the law is finally there. The changes are finally going to come. But yet, some people are calling for a pushback, and then people are looking again and like, yeah, well, we don't have a wide enough technical consensus on whether we should implement that or not. So let's look at something else. Yeah.
James, Jake, do you have a take?
Oh, I think Jerome covered it pretty well. I would say that from my perspective, like reading through the specs, there the nice difference between say 3074 and 7702. 7702 is not permanent, so it gives a lot of the functionality that you get with like the invokers, or essentially being able to have an EOA act like a smart contract account, but it allows you to do it temporarily. And in the future, it might be something where maybe it's not temporary. So you might just convert, say, an EOA to smart contract account code. So that is kind of the fact that you could try it out for, say, one transaction, because it's just a transaction envelope change, seems really nice for people that don't want to just, more permanently hand it over. And then the other, what else was I going to say? Yeah, and I think mainly the big concern was that whitelisting of like the invokers. So if there was a better invoker, or there was an invoker that you wanted to use, like if you were a more technical user, it would be unfortunate if you were unable to use that with like the wallet you were using. So, but yeah, that's about it to add on to that.
And I have I'm gonna share a screenshot from a article from Bioeconomy, but basically it talks about 7702 being more compatible with the AA roadmap. So I'm just wondering if you have a take on it. Just let me share my screen really quickly.
I mean, I guess my 2 cents on this is that I haven't looked too deeply at 7702 being in Aztec land, but my take, like having seen 3074 when I was looking at the pre 457 sort of smart account logic that we were building, I just think, yeah, it's probably dated. Like it solved a problem. It was written at a time, the people in that had the headspace at a time, and then 457 is trying to solve something at the smart contract level, has been considered by a lot of people. And so this solution probably has more relevance in that sense. And then to say, let's have those people that have built that, those that are building around that, to have their say in what the next step should be or transition towards at the protocol level. And maybe that's what 7702 is. So to say that, oh yeah, let's just grab this thing that was designed in the past. And I'm not sure how up to date, like if it's been added to and amended over time. Again, I haven't been following closely, but yeah, that would be my 2 cents on it, just from a high level point of view, that taking something that's been worked on by more people more recently makes more sense than taking something that's maybe not been touched so much over that time.
So just to zoom out again and to give some context, 7702 was written kind of 90 minutes before the account abstraction breakout call by Vitalik, which is taking a lot of the feedback about what people didn't like about EIP 3074 and then rewriting it in a different way where it did not add opcodes and it used a new transaction type to embed the smart contract logic. I'm not sure if I've covered that correctly, but yeah, that's essentially what it is. And then the storage is deleted at the end of the transaction.
There will be several core devs and AA-minded person or AA-involved person in Berlin next week. So I expect a lot of discussion around 7702 to happen, and I personally didn't dig too much on the specification because I expect it to change and to move a bit in the next few weeks. So I'm saving my time on that. But yes, Dustin, you put it right. It's making the 3074 approach more aligned with the 437. Again, let's not be naive on the consequences of doing something like 3074 in terms of whitelisting the invoker, in terms of the invoker themselves as well. I see two extreme cases where this approach is very detrimental to our ecosystem in terms of level playing field and freedom to access and public good form of the things and self-custody, self-hosted custody of things and so on that we should pursue and put as a high goal for any user. Let's consider an hypothetical case where I have an account on say Kraken take a nice actor. I have an account on Kraken. Kraken give me a deposit address. Oh yeah, so Kraken is having a public key infrastructure for me. Why don't I use this key as my wallet, for example? So why wouldn't Kraken just say like, hey, you can use this as a wallet, and here's the Kraken invoker, and now I'm centralizing all the activity on my Kraken invoker, and I'm paying for your gas and so on, and I'm putting you back in a system that looks very much like the banking system right now. Or I'm a wallet as a service provider with like everything under an HashiCorp vault. I control everything, and I'm giving you this same type of access through my invoker, and I'm taking some fees out of you. With 7702, we are forcing that those transactions, those messages and those intents of doing a transaction are going through the mempool and going back with the entry point of 427, thus removing the centralization aspect of being able to handle both the signature and the infrastructure at the same place that 3074 would have led to, I think. And so I'm satisfied with what I'm seeing on the shared screen, and I hope it will be properly implemented and properly run by Q4.
Yeah. Just to also summarize some of the concerns that I've seen people express about 7702 that will probably be resolved or discussed in future calls are what the gas cost would be, and also the nonce management. So I think nonce management is one of the big ones that people express concerns about that were not yet addressed in the original draft, but I'm sure that will change over the few weeks. Okay, we're almost at time. I know a number of you have to jump off for a call, but yeah, I hope that this has covered a more in-depth dive from our first account abstraction call. We've gone deeper into the guts of like the different upgrade paths and the different groups, the different standards. So I hope that this has been illuminating for everyone, and thank you for all the guests for coming on and sharing your expertise with us.
Thanks for having us.
Thanks, Justin. Cheers.
Likewise. Thank